This lesson is the math side, and at the end I have a bunch of proofs, and whatever time we have at the end, we have 40 minutes, whatever time we have at the end, we'll try to get to them. You ready? All right. Geometry chapter 4 review. ABC is an isosceles, where B is the vertex angle. Just for funsies, let's remind ourselves of what an isosceles triangle is and the names of some of this stuff. This is a review after all, which means some of this, the vocabulary that I probably told you once and only once, the vocabulary is probably forgotten, and that's okay. These are called these are called the base angles. Okay, and the base angles are the same measure. Okay, the non-base angle, that's called the vertex angle. Okay, that's called the vertex angle. So when it tells me that B is the vertex angle, what it's telling me is that, and B, so B would be right there. So it doesn't matter which one's A and C because they're the same anyway. So A and C are exactly the same. So I can get rid of, I'm going to have those ugly looking arrows still there, but I'm going to get rid of this information. AB. Now, here's the thing. If these two angles are the same, then these two sides are the same. So AB is 20x minus 2, and BC is 12x plus 30. Eat your cheesy poofs. Which means they're the same. And then AC, air conditioning, is not the same. Okay? So in order for me to find the length of each side of the triangle, I have to find X. Oh, your army is stuck. Oh my goodness. Oh my goodness. Thanks for screaming. AB and BC are equal to each other. So I can set 20x minus 2, because that's AB, equal to 12x plus 30. I'll give you 30 seconds to try to find X before I do it. Did you eat your cheesy poofs? You drop more of them than you eat. Uh-oh, one fell to the ground, Here's the cheesy poof. I love cheesy poofs. You love cheesy poofs. If we don't eat cheesy poofs, we'd be lame. Eat your cheesy poof. Yes. All right. I'm only working with one monitor, so if you guys are in the chat, I can't see a thing. Baby, you have cheesy poofs. Achoo! All right, so I'm going to subtract 12x. God bless you. God bless you. Oh, little baby sneezes. 20x minus 12x is 8x. So I'm going to drop down the minus 2 and the positive 30. Okay, cheesy poof. I'm going to add 2 to both sides. Yes. Uh-huh. 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 And that gets me 32. Your leggies are stuck. That's the problem. Ridiculous. Fix your leggies. There you go. Much better. Oh, honey. Oh, honey. Look. Cheesy poof. Divide both sides by 8. Insane. And x equals 4. X equals 4. Now, let's do quick math. Our job here was to find x. Now, on the test, you won't see a problem this involved, but you might see problems about isosceles triangles, which would require us to... oh, come on, my love. Your leggy is stuck. That's the problem. That's the problem. Got our leggies stuck in our jammies. Daddy's going to attempt to write with one hand, which is going to be a near impossibility. We'll see what happens. All right. So again, the important piece to start out was the fact that we had isosceles triangles. Isosceles triangles, you have two bases that are the same and two sides that are the same. That allowed us to set the two sides equal to each other to find out that x equals 4, and that's part 1. Part 1 is to find out x. We did. Great. Now I have to find the length of each side. So since space is limited and my arms are limited, I'm going to do mental math. X is 4. So 20 times x means 20 times 4, which is 80. 80 minus 2 is 78. So AB is 78 centimeters. I don't know. What does that mean? That means BC is also 78. But let's just double check. X is 4. So 12 times 4 is 48. 48 plus 30 is also 78. So yeah, I guess I did it right. And then the last side is 25 times 4, and I can do that in my head. That's 100. No units. Boom. My picture is drawn poorly. Oh, Miss Harris is here. Miss Harris, I'm dad duty. So that's why my cousin's not here. And so if anybody's putting stuff in the chat, if you don't mind just answering them, I only have one screen going right now. So, but I don't know if I literally can't see what's going on in the chat. We have bless you, x equals 4. I second it. Okay, so good. She's a little rapper. Okay, so I didn't miss anything important except for she's a little rapper and 2 answers. Good. Again, the point of this problem is on the test, you won't see something this involved. It's just the importance of this problem is saying that's an isosceles. So 2 sides are the same, 2 angles are the same. Now what do I do? And so this kind of covers all the possibilities of an isosceles triangle. Please don't touch my screen with your cheesy hands. Oh my goodness, I just love babies. Here, they don't need to see my bald head. They can see your adorable face. All right. Find the length of the sides of the triangle with, we're going to skip that one. You won't see that one on the test. You are taking a long time loading. All right. Okay. So you will see a problem like this. Again, not as involved, but the idea is still there. Maybe you will see a problem like this. I don't know. This is how I view this problem. This is how I view it. Montel Jordan? I don't remember. See how these 2 angles, when glued together, make a straight line? When 2 lines are glued together and they make a straight line, that means those 2 angles add together to form a 180-degree angle. So this angle down here and that angle right there add up to make a 90-degree angle. So the way I find x is I do 3x minus 10 or plus, that was a close one, 8x minus 30 equals 180. The idea behind this one, again, is when 2 angles, no matter where they are glued together, and when you have those angles glued together to form a straight line, those 2 angles add up to make 180. So 3x and 8x are 11x. I'm waving my hands a little bit because, you know, space is an issue. And, of course, my handwriting's an issue because I can't hold this. Minus 10 minus 30 is minus 40. If you guys are in the chat and you want to beat me to the answer, that's perfectly fine by me because this looks terrible. Although the answer is going to be pretty convenient. I'm going to add 40 to both sides and not write that step out. I have 11x. If I add 40 to both sides, that cancels out, and that turns into 220. God is good. Because if I divide both sides by 11, x equals, let me see if anybody has it in the chat. 20, says Paul. My man. My man, Paul. My man. You are just a little ray of sunshine in the morning. Okay. Boy, do I just love you. Now, if angle 1 is 4x plus 10, I'm supposed to find the measure of angle 1. So let's do that. 4 times x, which we just found out to be 20, plus 10. I will literally give you 5 seconds. 5, 4, 3, 2, 1. We're going on a trip in our favorite rocket ship. Your hand is so messy and cheesy. Does anybody have it? How come no one typed out 90 yet? There's Athena. Can always count on you. So the measure of angle 1 is 90 degrees. Okay? Let's get rid of this whole mess. If you're like, no, I wasn't done. It's on the internet. Okay. The most important thing to finishing this problem is understanding that x is 20. That allowed angle 1 to be a perfect 90 degrees. I have to find the measure of angle 2, and it gives us 0 information about it, except for the fact that what I have right here is a triangle. Angle 1 is 90 degrees. Angle 2, I can easily find, because if I have 3x minus 10, then angle 2 is going to be 3 times 20. What's 3 times 20, baby? 60 minus 10, which is 50. The angles in a triangle add up to 180 degrees, which means the measure of angle 2 is going to be, and I'll give you 10 seconds to put it in the chat. You could do mental math on this one. Don't go crazy. 40. So I could do, the measure of angle 2 is, well, the whole triangle is 180. I already know that top one is 90, and that right one is 50. And so 180 minus 90 is 90, minus 50 is 40 degrees. I'm not right, little peanut. Okay. You should be able in the chat to give me one of these answers already. So either type out x equals or y equals and tell me which one. The vertical angle is so 30. Which one's 30 then? Y. So with vertical angles, I should be able to say that these two guys are the same. Y is 30. What shape do I have over here? And how do I know I have that shape? Spell it the best you can, because I don't think I can spell it without it in front of me. What shape do I have on the left? Hey. Babysitting has arrived.
Yeah.
Well, no one said it, so I'm going to say it. Isosceles. How do I know that this is isosceles? Well, I know that this is isosceles because those little hoops imply that those two angles are the same, which means that you're 3x as well. So if I want to find the missing, if I want to find out what x is, I have on the left side a triangle. Ugh, and that looks absolutely terrible. Where 3x is an angle, plus 3x is my other angle. I just found out that y is 30, and all of that adds up to equal 180 degrees. You see Stanley dog. She loves our dog. She'll laugh at him. She'll just stare at him and laugh. He's a lummox. He's a maroon. So I'm giving you guys a solid 10-second head start to find out what x is. Athena, is that? Oh, never mind. That's a y. So take a few seconds to figure out what x is. So I got Samson with 25. And I tend to agree with him, as I usually do. These guys add up to make 6x plus 30, and it's going to equal 180. Subtract 30 from both sides. Six x will equal 150. Divide both sides by x, and that's where a 25 comes from. So again, as you notice, a lot of these problems are very involved. Very involved. It's not a matter of, just a simple... Hold on, I just switched over to my monitor. And of course, that takes a few minutes for it to load up. All right, here we are. So again, we see here, and that's another key thing that we seem to forget a lot with this section, is we dealt with isosceles triangles quite a bit, and we've seen that twice now. Okay. Good. Oh boy. In the figure, AC is congruent to FD. AC is congruent to FD. So let's write that out. And then we have... Now, this is an ugly problem. You won't see one this crazy. AB is congruent to DE. So these guys are congruent, which implies that And AC is congruent to FD, which implies that. Just now, that looks terrible. So let me, yeah, you know what? Finally, for once, I'll actually hit the reset button and it'll actually work. AC is congruent to FD. Boom. These two are the same. Remember, when we see parallel lines, we are thinking alternate interior angles. So since this line and that line are parallel, that implies that that angle and that angle are parallel too. That implies this angle then and this angle are parallel or are the same. So what do I have? Do I have three sides, three angles, an angle and a side? Just use logic right now. You don't even have to give me any of these yet. What do I have? Two angles and a side, two sides and an angle, three angles, three sides. What do I have here that are the same? Type it out. Two angles and a side. Two angles, one side. Good, I agree. So that eliminates you. And that eliminates you. So let's focus on one of these triangles. We're going to pretend this triangle doesn't exist. And by pretending it, I'm just going to literally black it out. It's gone. It's gone. Get rid of some of that color. Gone. What do I have? Do I have ASA or AAS? AAS. And here's why. I have two angles, boom and boom, and the side is not in between. If the side was in between, I would have angle, side, angle, which is ASA. But since I have angle, angle, and over here is a side, it's AAS. Very tricky problem. Very confusing problem. Will you see one that ugly on the test? No. And last night, my video for the 5 proofs that we did uploaded. So by all means, while you're taking the test, if you're never sure, fire that video up and make sure you understand, those problems, because you are going to see 2 proofs. And I'm not going to tell you what they involve, but that will involve SS, SAS, ASA, AAS, or HAHLLALL. All right. Don't be surprised if you see a problem like this on the test, because I look at a problem like this and I say to myself, that's not difficult. Who remembers and who can type in the name, and I don't care about spelling, the name of this type of triangle? Who remembers the name of this type of triangle? Equal something, equilateral. Good. I think it's EQUI, but who cares? I really don't care. It is equilateral, which means all the sides are the same, but it also means all the angles are the same. So there's so many ways that I can do this problem. Listen to all the ways that I can do this problem. There's 4 ways, I think, if I'm thinking correctly in my head, that I can do this problem. Since all the angles are the same, I could set these 2 angles equal to each other. Why those 2 angles? I don't know. I just picked them. Some of you might be like, well, no. I could set these 2 angles equal to each other, and you would absolutely be right. And some of you might be like, no. Since all the angles are equal, sir, if I wanted to, I could set these 2 angles equally to each other, and you would be right. And some of you might be like, well, no. This is a triangle, which means all the angles add up to 180. And so I'm going to say this blue one plus that blue one plus that blue one adds up to 180. That's true. But there's actually a 5th way that literally just popped in. Actually, there's a 5th, 6th, and 7th way that just popped into my head that you could do this. If all of the angles in the triangle are equal, that means each one of these angles will be what? They are equal, but 60 is the answer I'm looking for. Good. And I accidentally clicked the wrong button on my monitor. I'm trying to turn the volume up. All right. 60 is correct. So the other ways that I could do these problems is I can set you equal to 60. I can set you equal to 60, and I'm going to set you equal to 60. And probably the easiest one looking at all of these is the 15. So 15x plus 15 equals 60. And you might be thinking, well, Mr. Perich, will we get the same exact answer? Because I showed you 7 different ways that you can do this problem. And if you're thinking, well, I still get the same answer every single time, absolutely you will. Absolutely you will. So I'm purposely leaving that up there for those of you who want to try to beat me in a chat. Just don't beat me in real life. 2. Thinking it might be a little bit bigger than that, Camilla. And I'm thinking I like Athena's. Minus 15, minus 15, 15x equals 45. Yeah. Divide by 15, divide by 15, x equals 3. No matter how you solve this problem, and there are 7 different ways, or was it 8? I don't know. Either way, there were so many different ways. No matter how you do it, you're going to get 3 for x. And the way you can easily check your answer is, plug them in for x. I want to do this one. Yeah, I'm going to do this one instead. Sorry, everybody. Sorry, everybody. Sorry, everybody. Sorry, everybody. Erase those of you who are actually taking notes. I feel like we did this problem yesterday, but I could be wrong, and who knows? Who cares? MJ is equal to ML. So we're given one set of sides. K is the midpoint of JL. Okay. That first statement says that I have one side already. That second statement says that I am allowed to set 2 things equal to each other. What 2 things, according to K, is the midpoint of JL? What 2 things am I allowed to set equal to each other based off of that second phrase? When you see K is the midpoint of JL, you should say, I know what that means. Blah equals blah because of the definition of midpoint. Please put it in the chat. You'll see these problems tomorrow. LK and KJ. So since K is literally the middle here, we could say that LK, and how did you write it out? KJ are the same. LK is congruent to KJ. Now I have 2 sides that are equal to each other. What else can I say is equal to each other, and why? MK, or MK, if you like that show from a long time ago. 1, 2, 3. And why is that? Why is MK equal to MK? Reflexive. There's a kitty cat at my window. Reflexive. The old San Diego special. Now I have a side. Well, I can now say that these two guys are congruent to each other. I can now say that triangle MJK is congruent to triangle MLK, Martin Luther King. And why am I allowed to say that? What property am I allowed to use to say that? Yes, because I have no information about angles. I have a red side matching up with the red side. I have a black side matching up with the black side, and the green side is itself. Side, 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 side. Good. SSS, or as a snake would say. Ooh, time. I'm not going to be able to get the entire proof in, but let's explain this one. We have parallel. Well, first off, it tells us that that side and that side are congruent. It says parallel. So what three-word phrase am I going to use whenever it says parallel? We've done this already today, so you should know this by now. It's also on my Instagram. What three-word phrase should you think whenever you see two parallel lines? Two lines are parallel. You should automatically jump to no one is saying it. Alternate interior angle, says Jill. So that gives me those angles are congruent. So I would say that. These angles are congruent. And now I can prove that these two triangles are equal using ASA because I have two angles with a side in between. I have a cat who's desperately trying to get in, but he has to stay outside because he's in trouble. No, Freddy! He's in trouble. It's going to be 60 degrees outside. Chill, bruh. Chill, bull. Maybe you need a cat counselor. Ooh. I might have a cousin who's a counselor for cats. Or I might have a cousin who's a therapist for cats like that guy on the show. Let's see what else I have. I'll give $1 million to anybody who can tell me what you think that this is going to be. Just by looking at it. First off, what three-word phrase should pop in your head like right away? Oh, well, first off, I like this one. And let's quickly do this one. I see right triangles or right angles. That won't work. I see right angles, which means I see HA, that will work. And I think HA will be the only one that will work. Here's why. There's a magic phrase again, parallel, which means I can do this. Wrong one, sorry. I can do this. I can also do this. Now, there is no such thing as an AA. So as much as I want to be like, oh, great, two angles with right triangles, I only have to worry about two things. There's no such thing as an AA. But what could I look at right now and just automatically say that they're exactly the same? What are exactly the same right now just by looking at it? AC, because of the Santa Maria special. So I have a hypotenuse. I have an angle. And I like this because it makes me laugh.